Right. Hope everybody can hear me fine. Thanks, Chris, for that introduction. You know, Again, I'd like to thank everybody for showing up for this. It's an absolutely gorgeous day where we're at, and I know days like this time of year, it's easy just to kind of skip out and go for a walk or an early long lunch. But you know, I wanted to double stud wall assemblies. I guess I wanted to start out my webinar sessions this year with a kind of a controversial topic. Um, you know, it's as we get into different things here with what we're looking forward, as far as efficiencies go, increasing R values, the potential for changes coming down the pike. I kind of wanted to talk about a way to to be able to increase R value without having to make things an overly complicated process. So, for me, I have a little bit of experience with double stud framing. I don't know, I've met some of you. Most of my construction experience really focuses in the southeast, and in the Asheville, North Carolina region, actually the coastal regions of South Carolina and the mountains of North Carolina. So that down there, that zone, really, we weren't looking to push super insulation at that point anyway, where I was at down there. I'm not sure exactly what they're doing in the mountains down there now, but as of then. But I was always familiar with double stud framing. I always was intrigued by it. So that's one of the reasons why I picked this program in this topic. So what I want to do today is sort of just give an understanding of the components of a double stud wall assembly, and show how a double stud framed wall can allow for increased R value, decreasing air permeability, and also another benefit is lowering the exterior noise pollution. Identify the benefits and the drawbacks. I know that some people feel that there's a lot of drawbacks, and we'll try to get into that, on not on a super deep level, but on a level I think we can all understand. And of course, examining the potential risks within the double wall assembly if improperly designed. I mean, that's I think something that we can say to any wall assembly. If it's improperly designed, there's inherent risk to those. And of course, as we say with all our webinars, this is where we're at right now in Pennsylvania. We're in the 2018 code book. So I know 2025, we're looking at revisiting that, or they're looking at revisiting that and exploring options moving forward after that year. And there's potential for change to what we're dealing with right now. But again, here we are, we're 4, 5, and 6 in Pennsylvania. And I kind of threw this one in here too, because I kind of wanted to explain some of my references for builders and where they're doing most of this construction that I'm referencing is up in the Massachusetts, Connecticut, New England area. But as you can see, especially Massachusetts, they're within our zone of construction. I know zone 5, zone 5 in Virginia is different than zone 5 in New York, but our weather and our climate zones are pretty similar, to where they're using this type of framing more than we are down here. And of course, the 2018 IRC table right here, I have highlighted here what I'm going to sort of be referencing. What I'm going to be talking about is what we're currently following. We know we have R20 or R13 with 5, and then 4 is the same. In zone 6, we get a little bit more intense. We have R20 with 5 and R13 with 10. The changes, potential for change, if we do move to the 2021, is a little bit more intense. We're going to be requiring an R30. An R20 is then still going to be there, but you're going to have an R5 of continuous insulation on the outside. If you're going to stick with an R13, you're going to have to bump that up to 10. And if you choose for some reason to have no insulation in your walls, you're going to need you're going to have the option of an R20 of continuous insulation on the exterior of your building. And this is what the table looks like in that code. The nice thing about this is they're all the same. You know, there's not really a variation from 4 to 6. Okay, what is the perfect wall assembly? Why am I asking this? Because we get questions quite a bit, or I get questions quite a bit of, you know, somebody saying, just tell me what I need to build. What's the perfect wall that I can just build and just be done with it? And you know, as Joe Seabrick said, the perfect wall is an environmental separator. It has to keep the outside in and the inside out. And it's as simple as that. But there is no real perfect wall assembly that you can just build and just use it from location to location. You know, obviously walls we're designing with 4 control areas in mind. You know, we want to control the rain, we want to control the air, we want to control or deal with the vapor situation, and thermally we want to be able to stop the movement of heat or cold within our assembly. And I say the perfect wall assembly because what we really I want to say is, like, even here in central Pennsylvania, in Center County, if you were this is what I tell people: if you were to build a house on top of a hill where it's sunny, you have no trees, and you have it's breezy up there, and then less than a mile away, you could be down in a deep valley where you're surrounded by trees next to a stream, and you might get the sun only 3 hours a day. You're both within zone 5, but you have 2 completely different construction environments there. So there is, you know, a perfect wall assembly, but there's just not one that you can just use, in my opinion, across the board and be really comfortable using it. You know, double wall stud framing is maybe considered advanced framing. It's not really optimal value engineering framing. What this is here is just you know, more efficient way of framing a wall. So you're using less wood in that assembly. You can get more insulation in that assembly. And that's really where this started is, you know, obviously you're going to save money by removing the wood and streamlining your framing, but you're going to be able to increase the R value of your wall assemblies by framing this way. Why double stud wall for me? In my opinion, it's a very uncomplicated, unquotes, system of framing. Like with any other type of advanced framing or framing assembly, you can make something more complicated if you want to. And then there's reasons why you might have to make that a more complicated assembly. But on a really basic level, a double stud wall assembly is just basically 2x4 framing with another set of 2x4 framing in front of it. Anybody with basic carpentry skills and basic carpentry knowledge can frame a double stud wall. It has a potential for extremely high R value. Obviously, as deep as you want to make this cavity, you can increase the R values, reaching R30, R40, even up to R50 if you want to. Another benefit of double stud framing is you virtually remove all thermal bridging. Obviously, you're going to have a little on the bottom, you know, where your sheathing transitions from the exterior to the interior. But if it's framed properly, you know, it's an excellent way of removing most thermal bridging from your wall assembly. Expense. This is where it gets a little tricky. You know, if you're just talking basic materials, you know, framing a 2x4 wall 24 inches on center doesn't use a whole lot of material. Yes, there's labor involved, but like I said, if you have a pretty decent carpentry crew, for them to frame a 2x4 wall 24 inches on center shouldn't take very long. Especially if you're just going to mirror that wall exterior to the interior, your layout's mostly done for you. Mine is, obviously you're not going to use the same amount of stud. You're not going to need to use header studs, jack studs. There's things that you can leave out that you don't need because it's a non-bearing wall. You're basically hanging sheetrock and holding insulation within that assembly. And one benefit is it reduces noise pollution. So if you live in town or if you live next to a busy road, this wall is much quieter than a traditionally framed wall. I think a lot of people might have seen some variation of this assembly, which called an offset wall that people use on the inside of houses, maybe to separate a bedroom from a living space to help reduce that noise pollution, that noise transfer. The level of complexity, there are many different variations of a double stud wall. The most basic traditional sense, it's just a 2x4, 16 inches on center. And you can go up from there where you're doing different versions of this. There's a version that you use a Larson truss that's actually hung on the exterior of a wall. So you'd basically shift your bearing wall from the exterior wall to the interior wall, but that exterior wall is also pushed to the outside and it's hung. We'll talk a little bit more about that later on. In areas where it's heavier wind loads, you might still be required to do a 2x6 framing. And you just might feel on the exterior, not the interior. You just might feel as a builder, even if it's not required, that's something you want to continue to do. And there are options. You can frame a 2x4 wall, 2x4 wall, 24 inches on center. It might be a good idea to get an engineer sign off on this, just to be sure. I'm talking about the exterior, not the interior version of this. Again, as with all decisions when developing a wall assembly detail, climate zone is key. Pay not only climate zone, just location of where you're going to be building this assembly. And like everything, you can make this as simple or as complicated as you want. And here's an example of a simple 2x4 assembly. It's framed 16 inches on center. They're using plywood sheathing, which is important. The second interior wall is framed 24 inches on center. You have a rough opening for your windows and doors, take into account the thickness of a wall gusset. So what they're doing here is they're framing both their wall assemblies. And when I'm saying that, take into account the thickness of your plywood, when you're framing your rough openings for your windows and doors, you're going to need to use what a gusset or just sort of bridge that's going to fill in that gap between those so your insulation doesn't obviously come through or fall through. Basically building a box within there. And if you use 1/2-inch plywood on that, you want to take into account your rough openings and expand your rough openings the adequate amount to compensate for that plywood. The worst case scenario is if you didn't do that, then you already have your windows ordered, then you're in trouble. And it's a complicated mess to deal with. And a vapor permeable WRB in this assembly. So that's important because what this wall assembly especially is doing is especially using the plywood, it's very open, it's very vapor permeable. It's going to dry very quickly in both directions. And by using obviously a vapor permeable WRB, you're not hindering that wall's ability to dry to the exterior. And of course, they're using a 1x3 rain screen, which is a good idea because you're just increasing the efficiency of the drying of that wall by having that extra opening space between your WRB and your siding. Benefits of 2x4, obviously, if you've been in this industry for a while, you remember framing with 2x4 mostly years ago. It's super simple to stand up a 2x4 wall. It's light, it's easy to handle. When it's on the ground, you're able to apply more components to that assembly, and you can increase the weight and stand it up. 2x4s are cheaper. And in this diagram here, this assembly here, they're assembling the entire wall assembly. They're adding their WRB. And in this case, they're using a type of a SIGA WRB that's vapor permeable, but it's self-adhering. So using plywood, obviously, if you're going to use it as an air barrier, you want to make sure that you seal all your gaps with tape. By them using this type of WRB, they're basically using that as their air barrier as well, because it's self-adhesive. You can use any WRB really that you want that's vapor permeable, but you're going to have to take into account, all right, I'm going to use my plywood as an air sealing. I'm going to have to tape all my seams just like you would like on a zip system or anything else like that. Yeah, of course, cost of materials is lower with 2x4s over 2x6s. Now, there are different variations of a double stud wall assembly. You know, one that we've seen recently here in State College on a retrofit was they use a Larson truss on the exterior of the building. A Larson truss, if you're not familiar with it, is just basically a site-built assembly that kind of resembles an I-joist, but it's not technically not an I-joist, but it's used in this application right here on the exterior. You know, the assembly here, like the one in town here, they just removed all the exterior siding. Anything right up to the wood sheathing is what they removed, and they hung their trusses on that. And they built them in place. So, you know, you're going to attach your, 2x whatever it is material here that your engineer has spec'd, apply your plywood gussets and go on from there out. It's a more complicated way of building, obviously, but in situations where you don't want to lose floor space, you want to keep your interior as open as possible, especially if you're retrofitting an older house, which already has a small footprint. This is a really good option. But this is going to take, some more exploring. If this is your option or that you want to explore, it's going to take a little bit of work on your part to really understand how to do this best. And here's something that people are using now on an exterior wall. It's the offset or staggered stud. It's similar to a double stud wall assembly in the sense that you've created that thermal break by offsetting your studs. That most of the time these studs are 1 foot on center, staggered back and forth. Then cellulose or blown or sprayed fiber, sprayed foam is the insulation of you're going to have to use here as well, because it's just no way to use bats efficiently and try to get them within that assembly without compression. Again, the difference between this and a double stud is you will have some more thermal bridging at the top and the bottom of your wall assembly. And obviously, if you're going to move up in R value, you're going to need a bigger than a 2x6 base plate. Then you're going to start to looking at 2x8s and 2x10s, and then at that point, your weights and your numbers of cost are going to start to have more of an effect than looking outside of a staggered stud and moving back to a double stud assembly. And there is a little bit higher level of complexity. I can imagine myself framing this wall. It would be difficult to frame it laying down, more difficult than just a standard 2x4 wall framed on the ground.
Comment that kind of came in the chat pod talking about an instance where they did the 2x4 that was the staggered stud, and it sometimes based on this comment, it looks like it doesn't always come in with the best rigidity. So they used an LVL for the single top plate, and then used the 2x8 standard proprietary or standard 2x8 for the bottom.
Yeah, thanks, Brian, for that. That makes great sense. And I think what Brian was saying is, if people haven't had the chance to read what his comment was, he does an offset, but he uses LVL's single top plate and a 2x8 bottom plate. Again, this to reach the goal that you want to reach, there are lots of ways to do this. And if this is your place of comfort, and I appreciate him sharing that with me, because yeah, that is a great idea. Go with what you feel comfortable with. You know, I as I get older as well, framing to me is something that uh, I enjoy doing. But for me, I sort of am leaning towards this double stud assembly for the reason of ease, simplicity, material choice. You know, you can get a 2x4 almost anywhere in decent shape. The bigger you go with lumber, you know, the longer lengths you get. You know, we all buy lumber from different places, and it sometimes can get not so clean. So again, do what makes you feel comfortable. And for me, you know, like I said, this is appealing to me for many different reasons, and I'm trying to explain that as best I can here. So moving on a little bit, with a double stud assembly, and the one I'm talking about, and the one that I showed you earlier, which is this one here, they're using plywood sheathing rather than OSB. And one of the reasons they use plywood over OSB is it's a permeable. It dries extremely well. Plywood and OSB have about the same permanence when the mean relative humidity is low. So if you're in a house or you're in an environment and you have a relatively low humidity level or moisture level, they're both going to operate on the same level. Where it changes is as the relative humidity increases. And as this graph here would show you, plywood is way more permeable the wetter it gets than OSB is. It can be pretty significant. And if you have a thick wall assembly like a double stud assembly, and you're drying in both directions, which is ideally what you want to be able to do, using plywood over OSB is just going to give you a little bit of a more vapor open avenue of escape for that moisture. You know, obviously there's drawbacks to both, and plywood and OSB don't cost the same. Plywood is more expensive than OSB, obviously. But you know, again, that's a trade-off. OSB is permeable, and I'm gonna, don't quote me 100%, but I think it can get up to about 10 to 12 perms. So it is semi-permeable, I guess is what I want to say. And I kind of laid out a little bit of my pluses and minuses of both. You know, plywood, it's very permeable. It dries extremely quick. Quotes, it's not going to dry as quick as, you know, the cellulose insulation inside, but it has the ability to dry relatively quickly compared to other options. It can be used as an air barrier. Obviously, you're going to need to treat the joints as if you're using, say, a zip systems, and taping the joints is something you're going to do with this system as well. So there's that expense added on there as well. And you will need a WRB with this. You know, OSB is semi-permeable, so it can dry. And there are people using OSB in this type of assembly up in zone 6 up in the north, with success. You know, it's obviously it's an air barrier, and you have the option of an integrated WRB as well. And there's a few different companies that have that. You're all familiar with those, I'm sure, at this point as well. And once you do determine your exterior sheathing, air shielding is just the same way as any other assembly. Again, the simplicity of this, you're not learning something new to use a double stud wall assembly. If you're going for passive house and you want to build an R40 wall assembly, it's the same. It's just the same steps, same materials, A little bit more thought, but the complication factor is the same. And here's just a few different ways of doing that. I included some pictures of different, obviously Tyvek is a WRV, and Tyvek can be used as a vapor barrier as well. In the assembly here in the middle, they're using OSB as a vapor barrier in the ceiling. The company I referenced a little earlier that does use plywood as their exterior sheathing, they actually use OSB in the ceiling of their second or first story, whichever one is their air barrier, and then they tape the seams within that. Again, there's multiple ways of creating an air barrier. It's the same air barrier that you're using now. If it's drywall, if you're going to use a fabric air barrier, if you're going to use OSB in your ceiling, that is the same. Even that doesn't change just because you're using a double stud assembly. Let's see. If you're not using an OSB integrated with a WRB, you will need to plan just like any other wall assembly. I'm kind of talking ahead of my slides here. And depending on the type of siding, a rain screen is often recommended to help keep the wall assembly dry. This is just a good idea as much as possible. The bigger gap you can get in there, you're going to get better drying. Obviously, using vinyl siding, that in and of itself does a pretty good job of keeping the air flowing within there. But if you're using like a hardy board or some other type of siding, that gap is essential to helping get the moisture out from inside of your wall. Like I said, if you're using plywood, that plywood gets damp. The more air you have coming across that surface, the faster that air is going to pull that moisture away from your building, and the faster your interior assemblies are going to dry. It doesn't only help with just the water that's striking your building, it actually is a benefit to drying the interior portion of your wall as well. That's, in my opinion, a rain screening is vitally important on both those factors. Insulation. The right insulation does matter on any wall assembly. With a double wall assembly, we have cellulose options. You have fiberglass, bat insulation, spray foam insulation. The two most common insulation you're going to find in this type of wall assembly, this thicker wall assembly, is cellulose and spray foam. Just because it's the thermal bridging factor, you're trying to fill in spots and locations within this assembly that if you use bat insulation, it'd be really difficult to tuck it into these corners and put it between the top plates and the bottom plates. So, spray foam and cellulose are the two most common options you're going to see generally with this type of assembly. Ian, with the offset that Brian had mentioned, what he uses earlier, he uses a blown cellulose. Like anything, especially with cellulose insulation, who installs it can make a huge difference to the quality of the installation. You want to know the guy or the girl, or whoever's installing this installation for you, is doing it the correct way. They understand how to get the right pack. They understand how to make sure it gets everywhere it needs to get. Cellulose in the technical sense doesn't settle. It's treated in a way, and it's treated with moisture, and it's treated before it's put in there to sort of create a continuous, not air barrier, but a continuous level of insulation that over time should not settle. And that's where the quality of the installer comes into play here. Don't go with the cheapest option, go with the best option. And if you've never used cellulose, talk to other builders, talk to, if you belong to your local builders association, reach out to those guys who are using this ask them who they are using, and and get those recommendations, because it makes a huge difference. If you've seen poorly installed bat insulation, the installation of the insulation is critical to getting a true R value. Okay, there's a lot to like about cellulose in this application. Obviously you have a pretty good R value. You get about online they recommend, say they get about 3.7 per inch. Again, a good installer is going to make sure you get the optimum R value for the depth that you're going to get. It's an excellent air barrier. It doesn't stop air infiltration, but it does a good job of sort of helping to eliminate that convection effect within a wall cavity. It's going to slow the air down. It's going to help you in that aspect of your assembly. And cellulose is hygroscopic, which means if it does get damp, if it does get moisture within the assembly, it's going to move that moisture relatively quickly, and it's going to even it out over a larger area. So you're not going to have a wet ball of insulation, and the moisture shouldn't hang out in that area. It should begin to move it rather quickly out and away, which allows for the drying effect to happen. Some insulations, they get wet, they tend to stay wet, and they don't do a good job of moving the moisture around, or helping to dissipate the moisture out of the building. And it's carbon negative, or at least carbon neutral. It's mostly a recyclable product. It's not, if you read about it, even in the manufacturing, they count the manufacturing part of the paper all the way through the recycling process, and it's still either carbon negative or carbon neutral. So if that's something that you care about, or if that's something that your company is striving for to reduce the carbon footprint, or if that's what the client you're trying to sell this product to is, that's a major concern of theirs, or a major selling point for them, is like, hey, we want to reduce our carbon footprint as much as possible. Cellulose is an excellent way to do that. And of course, it helps reduce noise pollution. It's good at dampening the noise coming from the inside to the outside. And here's a little chart that kind of shows that, carbon issue that we hear so much about. Cellulose right here, dense pack, is about what they're saying is -1-ish, some in there. And if you come down to spray foams, they're getting better. They're really depending on if you're an HFC or what type of spray foam. It can be in the +2. It can be, a little bit heavier in the carbon side of things. And there's less energy use or demand needed to create the cellulose insulation and blow in the insulation than there is to other types of insulation as well. Yeah, Mark asks in the chat here, is a rain screen effective in low humidity environments out west? I think a rain screen is effective everywhere. I'm assuming that's the question. Yeah, I mean, a rain screen is just, in my opinion, is a good thing to do, a good option for everything, no matter where you're building. Yeah, it's again, the reason I mentioned the rain screen was just for drying and durability factors. Spray foam. Spray foam is an excellent insulator. Obviously, if you're using a dense one and closed cell, it's up to R7 per inch. Again, this is one of those areas where you got to be extremely careful on where you're using spray foam. Spray foam 15, 20 years ago, it was just used. Spray foam is going to fix everything. It's going to be a super insulator. It's going to seal all the air gaps. And it is an excellent insulator. And it does a good job of helping control air. But you can have issues with there as well, especially when it comes to moisture. And you want to make sure that if you are using it, you're using it in the right location, within the right materials. Um, it's just a little bit more unforgiving, in my opinion, than you're going to have with cellulose. All right. All right. Okay. A little bit of thought here. Some modeling, when I first started really reading hard, a decade or 15 years ago about, double wall assemblies, they were talking about modeling, and some modeling was showing, 12 inches of walls insulated on the interior side of the sheathing will have an elevated moisture levels well above the 20% for prolonged periods of time. And that makes sense if you just quickly think about it. If you're like, all right, I'm going to have a 12-inch wall, I'm going to have lots of insulation. Um, you know, the exterior sheathing is going to get cold in the winter. Yeah, I mean, it seems to me like that moisture is going to travel through, it's going to get trapped there, and it's going to soak my sheathing, and I'm going to run into some major problems. Obviously, that's a possibility. You never want high levels of moisture against an exterior sheath wall, especially if it's an OSB wall, for extended periods of time. A little bit of moisture is fine. The key to that is how fast that moisture leaves. Is as fast as it gets attached to that wall or into that wall, you want it to be able to leave that assembly, that sheathing, just as fast, if not faster. Looking at the modeling number begs the question, how realistic are these warnings? There's some articles, you can find them all over, but I'm sort of referencing here in Green Building Advisor. It's a little bit of an older article, but they were talking about the dryability of double wall assembly. And one of the things that they were finding with these early models was the numbers that they were putting in to get the results. And some of the numbers that they were throwing in there were having a high interior humidity level is up to 90%. That seems pretty high. And I think for a while there, when they went back a little later and looked at those numbers, they started saying, all right, let's try to cap this at 70% interior humidity. And that's still really high. But again, these are models that they're using for design standards. So realistically, I know within my house in the wintertime in my basement, I run a dehumidifier. Upstairs, I have, not the greatest, but I have forced hot air. So my house is pretty dry in the winter. My moisture level concerns on the interior of my house actually are pretty close to zero. I have a pretty good exhaust system within my bathrooms. I just got to train my kids to use them the way they're designed to be used. But realistic humidity level I'm just going to say for myself, and I would say an average is you're looking at 60 to 40%. And that we know now how we build now with all the tighter houses, builders are having to use HRVs and ERVs, so our movement of moisture in our house is more controlled. Our bathrooms are doing a better job at removing moisture and recovering that heat. So in our kitchens, but there is still that relative humidity that's kind of trapped in there in the winter that we get. So in the summer, that's completely different. Then we might be getting up into the higher numbers, especially in the lower below grade areas of your house. And this is kind of something I thought about not putting in there. It is important to understand that these numbers are for design standard. They are using extreme conditions due to the fact that average homes generally do not fail. Yes, I'm going to say this, average homes will fail. You know, if they're done right, if they're done everything like you're supposed to do, there's still that chance of failure. And I also think we could take into the human factor here. I think the better you build a house, uh, the better you use the ventilation systems and the recovery systems and all these things, your house gets a little bit more complicated, maybe not to build, but maybe to operate. And this is where the education of the client becomes more and more critical. One of the studies I read about with the double stud wall up north was they were having issues with, yeah, they were seeing numbers on the interior of the wall assembly in the wintertime that were spiking up to 40%. And they couldn't figure out what was going on until they went and talked to the homeowners, and apparently there was a failure, there was something had broken within their ERV. So they weren't exhausting the bathrooms like they should be. They fixed that issue. For some reason, the clients never told the builder about this or the people running the study. And then 2 weeks later, the numbers were back down to within manageable numbers and appropriate numbers. So yeah, I mean, you can have failures within any assembly. It could be a building failure. It could also be an operational error as well, where it's just not being used. The house isn't being used like it technically should be used. Because mold is something that we want to be conscious of. Mold and fungi need at least a 20% moisture to grow. You know, below there, you're pretty safe. And obviously, in the dead of winter, this is not going to be as big a concern when it's summertime. You know, mold's not going to grow in a frozen or really cold environment. It will grow, and in this case, what they're saying is above 28 degrees. I'm going to guess it's going to be extremely slow and extremely difficult growth at that temperature. And what I've seen, what I understand is below 50 degrees, it really you begin to retard the growth of these things as well. So, but yeah, you know, it's that magic number I think most people are aware of is that 20%. You know, there's one of the studies that I kind of was reading about. It's a monitored field study. It was took place in Massachusetts. It's a zone 5. The house was built and it was R40 insulation, a double studded wall with cellulose insulation and an OSB sheathing. They used a gypsum wallboard primed with a 0.5 perm vapor retarder, which I think is an excellent idea. Because you need that vapor inhibitor on the inside. It's always a great idea to have that vapor inhibitor on the interior of your structure. You can use a primer. You know, you can use one of these smart membranes that they have now. They're kind of expensive, but they work fantastic. I don't know the chemistry or the mechanics of those things. I'm assuming they just work. But anyway, in this system, the cladding was a vinyl siding, which is a well-ventilated siding. They monitored this house on the north and south sides, and they just let the people live in it. And they found most of the year, they were getting a reading on that exterior sheathing of around 10%. There'd be slight variations up and down, but the worst reading they were getting was in February, when they were getting readings right at 20%. But they were also finding that by the time April rolled around, those readings were back down to 10%. So it's telling them that, yes, they are getting higher than desirable numbers, but it's drying in a way, in an efficient way, that really that 20% should not be a factor in contributing to problems within that assembly. You know, I don't know how long this field study took place. It was over a few years. Whether it's still going on, I'm not really sure, but it's worth maybe going back and asking, like, is there a way to get a longer field study? We're getting some pretty good questions here. You know, Jake asked, can you use foam board with double studded walls in this application? I would say yes. It's the same as any other framing application. You technically can use foam board on the exterior of a house. You're gonna have to deal with a lot of different things. You can technically, if you're willing to install other methods of dealing with shear, eliminate your siding as you're sheathing and put a foam board on the exterior of your house. Yeah, by adding that layer of foam board on the exterior of your house, you are raising the temperature of your sheathing, just like anything else. But then again, you're adding the expense of the foam board that hopefully you're trying to mitigate by using a double studded wall in the first place. So I'm not saying it's not a great idea, because it is a great idea. It's just potentially adding expense that you might not need. Double studded walls. Another comment is double studded walls double the labor cost for all practical reasons. I have a commercial project with double 12-inch TJIS filled with dense packs still standing. I got to say, I don't have experience on the commercial side with that type of framing. Obviously, my experience is double stud framing is within residential. With a good, like I said, with a good framing crew, most of the framing that you're going to, and with this type of framing as well, you're going to see people do it 14 different ways. You're going to see people put the exterior 2x4 wall up, then they're going to stand the next 2x4, your double stud wall up, and then they're going to cap everything with, they're going to run a strip of OSB or plywood on top to tie the walls together. Then they're going to set their trusses on top of that. You're going to see people who are going to frame a house entirely and come back after the fact and stand up a double studded interior wall within that. That people are going to say, yeah, it's going to be difficult to stand up a wall. You're going to have to make that wall a little bit shorter just to be able to stand it full on up. But then, what they're going to do is they're going to come around, they're going to throw spacers in there so that they can tie that top plate to their framing member, their roof truss or their floor system, whatever they're using to frame in their ceiling. I wish I had more. This is Thomas. And if somebody else can talk to this, I have a commercial project with 12 inches of TJI filled with dense packs still standing. Yeah, my commercial experience is pretty limited. My commercial experience, I got to say, Thomas, is mostly with light commercial, single story structures, things like that. And where I was doing that work was mostly down south. So if somebody else can comment on that, that would be fantastic. I'm going to move on here a little bit. Okay. Summary: double stud wall assemblies are an attractive option for higher R value wall assemblies. They are relatively simple to implement. The caution is that this type of wall assembly has potential for being on the edge of between risky and safe. So it is important to choose the right materials with a high permeability rating, such as plywood over OSB. Again, we are moving into a type of building now where building science is becoming more and more important. We all understand the importance of paying attention to assemblies and how we put things together, how we merge materials with materials. Some work better than others. All wall assemblies are becoming riskier. It's how we mitigate those risks and how we think about our assemblies before we move on. Once we have that knowledge and once we have that ability to understand how to best build a safe wall, we can expand on that. Like with a double wall assembly, if you're going to do with an R30 and you get a client says, I want R40, and you have the system worked out that you're doing, you're just going to scooch your interior wall in a little bit. Yeah, it's going to be a little less floor space. And if they're okay with that, that's what it's going to be. But it's an easy assembly to put together. It's relatively inexpensive in the sense, once you get up to R30 and R40, I think the gap between the expense of all those extra studs and the extra labor shrinks because you're using more affordable materials such as cellulose and plywood. You're not having to use high dense foams. You're not having to use continuous insulation on the exterior. So it's just going to take some time and some mathematics to figure out what best works for you. Jake Sowers asked a question I want to get to. What are your thoughts on zero energy houses using OSB or plywood? I mean, you have to use, I'm assuming the question is just being asked because I talk about plywood and OSB. Obviously, zero energy houses are built all the time right now with plywood and OSB, so I don't see that as a condition of concern at all. I'm going to try to throw my email on here real quick. It's btw153@psu.edu. If anybody has any questions or comments about what I talked about, please let me know. If there's information that I can get for you, please let me know that as well. And if you're doing a project like this and you're within Pennsylvania, please let me know. I would love to come out. I'm looking for projects that I can visit right now that I can get some pictures and some information from. Thanks.
Awesome, Darrin. Thank you very much for that presentation. Seeing that you opened it up, I'll throw in a couple cents on my thoughts on the question coming in about the 12-inch TJIs. So, looking at what it takes to come up with a project, you're always balancing design, labor cost, and material cost. So to me, if we're looking at a job where we want to try to do a thicker exterior wall assembly, and as mentioned in the comment, you're doubling the framing labor if you're doing a double stud wall. However, if you go the other direction, you would be paying more for material for a solid sawn piece of material if you're doing 2x12s or whatever it may be, or a TJI. So I think it's a balancing act.
A quick thing to that, Chris, is it's kind of a misnomer to say you're doubling your framing cost. You're not doubling your framing cost. You're doubling a small portion of your framing cost. You're adding on additional labor just on that one wall on the interior. So you're not technically doubling your labor cost. You are adding a small portion of labor onto that overall assembly.
Right. So if your framing labor is relatively inexpensive, or even normal cost, probably it may be cheaper to go that route with doing the double 2x4 wall for your exterior wall assemblies. However, if for some reason framing costs are through the roof due to supply and demand of crews, whatever it may be, financially the best route to go with a single member in that area. However, I would also, state that you're probably not mitigating your thermal bridging at that point when you're putting in a single material. So anyway, just my comment on that is it really depends on where you are and what you're currently working on, what option works best for you in that situation. But okay.
Again, I just want to say thanks for tuning in. This is one of those topics that, has got a lot of history and controversy about it. But and I think it's one worth exploring. Like I said, we don't know what's coming up in the future as far as code. I'm not saying it's going to change, but 2025 is around the corner, and they're going to be looking at things that they want to possibly move to. And we might be moving to a more intense requirement. So, keep your options open, start thinking about the future, and hope you guys enjoy the rest of your day because it's gorgeous. Might not be this way for much longer. So I'll talk to you later.
Very good. Thank you all.